Hi everyone, continuing the topic about lists. Now we are going to see a behavior when we try to add things while we are iterating over it. So imagine that we are iterating over the list of names using for each, and we would like to just add some extra information, extra object. This is not allowed when you are using for each. And as you can see here, we have concurrent modification exception. This is the behavior that for each has. I'm not entirely sure how it works at like code level, but it kind of knows the size of your array list or your collection that you are iterating over it. So if you're using for each, it will be very difficult for you to just add things ongoing. If you have to use this kind of behavior, it's a good idea to either use iterator, something that we are going to talk in the future, or use the index form. But we have a problem here. Look, if I have here names.add, this will probably blow up my memory. I have I starting with 0, and then I'm going until names.size. So in the beginning, names.size will be 2. But when I finish the first iteration, because of line 20, names.size, by the time I get back, will be 3 and then 4. It means that by each time I'm iterating 1, like I++, the size is also going up by 1. This means it will never finish. As you can see here, it will keep adding numbers forever until my memory blows. Now, if I want to avoid this behavior, I can, for example, create here an auxiliary variable, and I can store names.size. And by doing this, I replace these names.size by the size fixed that we have here. So this means that it doesn't matter how many times I add something to this list, it will never change the size that we defined on line 17. And we will get back only 2 values. But if we just print everything inside that list, we will get Swanee twice because it's iterating 2 times. And as you can see, this also shows that we can have duplicated elements in this array list. Okay, so removing here. Now, let's talk about some other useful methods. For example, coming back here to names, sometimes you want to remove something from the list. And we do have a very useful method that is called remove. And we have a couple options. One is remove with object, and another one remove passing the index. And we have remove all or retain all. Basically, we remove everything from, if you have 2 collections and you pass the second collection to the first one, it will remove everything that's common, or retain, it will do the other way around. Now, the remove that we usually use, for example, remove with object or index, they are pretty straightforward. The first one, I think the easiest one, will be passing the index. So for example, if I remove index 1, I'm going to remove DevDojo Academy. And if I pass index 0, I'm going to remove William. And if I pass an index that does not exist, as you can see here, the length is 2. We get index out of bound exception. So basically, I don't know if you remember from the array video, if we were having an array here, it would be array index out of bound exception. But with list, it's just index out of bound exception. And we can also pass an object. In this case, would be a string. And by the way, this returns true or false if you are able to remove it or not. So basically, since string provides us the equals, when we are asking to remove a specific object from names, and this object is a string, the collection would just search for a William, something that the equals returns true. And if I have like lowercase w, you will see that it's not removed. And talking about equals and hash code, as you can see, the equals and hash code are called behind the scenes by the implementation, and that of course means that we cannot have primitive types. And why is that? Just because, for example, how would Java call the equals and hash code for primitive types that do not have access to any object? So for example, if I want to have a list of integers, I just have to create a wrapper, list integer, and then I can create another list and I can add numbers. But the thing is, how can I add a primitive type? Because we could have this. This is a primitive, right? And I can get this primitive and I can pass here. If you're not sure about the answer, you can go back to the wrapper classes video. But the reason is that we have the autoboxing and unboxing. So basically Java will change this primitive type into a wrapper. So that's why we are able to pass primitive types, but when declaring, we cannot use primitive types. So none of the primitive types will ever work with any collection. Okay, so now that we know the remove, we have two options, either remove with objects or passing the index, if you know. And another useful method is add all. For add all, let's create names2. And we have here names2. And let's say here we use my surname and here academy. So let's say I want to add all the names from names2 into the names1. Well, technically you could add through an array. You could iterate over the second one, just start adding to the first one, or you can rely on Java and say, hey, get the first list and add everybody. So basically, we don't know yet about generics, but we are adding any list. We can accept here argument of any collection that pass the test. It is a string, the objects inside the collection. So add all names2. And when we execute this code, you can see that we have everything inside of the names playlist, not playlist, but list. And another useful thing is I can even choose the index. So I can, for example, start adding this at the first position. So Ctrl Shift F10. And now you have Swanee Academy and then William DevDojo. So these kind of problems are there for you to just start using. The thing is, if you are searching for a job or going to school, there is a very high chance that they will ask you to do this manually. But since we are focused on the job market and on daily work, I will just show you how to work with Java. So in the next video, let's work with more lists, but now we are going to see how we can work with list and our custom object smartphone. So see you in the next video. Bye.